Next example of orthogonal trajectories. Find the equation of the system of curves. The cylinder to y is equal to x square orthogonal to its intersection with the hyperboloid of the one parameter system xy is equal to z plus c. So this is orthogonal word is there. So we have to find the orthogonal trajectories. Another form of the question is what? Find the orthogonal trajectory on the surface 2y is equal to x square of its intersection with paraboloid system xy is equal to z plus c. So the equation of surface is what? 2y minus x square. So denote it is by the notation capital F, and by using capital G denote the equation of curve xy minus z minus c is equal to 0. So this is one and equation 1 and 2. Then consider df is equal to 0 and dg is equal to 0. df is equal to 0 means fx dx plus fy dy plus fz dz is equal to 0, and the derivative is what? Fx means the derivative of this is 2x. Fx is 2x, and the derivative fx fy is what? Is 2 dy. Fz is 0, 0 dz is equal to 0. So we have, by dividing by 2, we have this x minus x dx minus x dx plus dy is equal to 0. That is y dx, and qx gx dx. So gx is what? Is y dx, gy is x dy, and gz is what? Minus 1. So minus 1 dz. So right here dz minus dz is equal to 0. These are the equation number 3 and 4. df is equal to 0, dg is equal to 0. Right here minus dz is equal to 0. Y dx plus x dy minus dz is equal to 0. And this minus x dx plus 1 dy plus 0 dz is equal to 0. These are the equation number 3, and solving these 3 and 4 by using Cramer's rule. So dx divided by 1 0 and x minus 1, yeah, right, dz minus dy divided by minus x 0 and y minus 1, and dz divided by minus x1, this minus x1 and yx. And so we have the values of determinant as minus 1, here minus x square minus y. And this is of the form dx by p, dy by q, dz by r, where p is minus 1, q is minus x, and r is minus x square minus y. Here this PQR are what? Direction ratios of the tangent line to the curve, and dx dy are the direction ratios of tangent to the curve, which is orthogonal to given family of curves. And therefore by condition of orthogonality, we have p dx plus q dy plus r dz is equal to 0. That is, we have minus 1 dx minus x dy minus x square minus y dz is equal to 0. That is dx plus x dy plus x square plus y dz is equal to 0, equation number 5. And now fz, fy, fx, fy, fz are direction ratios of normal to the surface. We have fx dx plus fy dy plus fz dz is equal to 0, because dx dy dz are the direction ratios of tangent to the surface. And so by condition of orthogonality, we have this, and that is minus x dx plus dy is equal to 0. Actually this is the equation number 3. This is again the equation number 3, fx dx plus fy dy plus fz dz. So right here equation 3 again, that is the equation 6, and solving this equation 5 and 6. So follow this process, only follow this process. For every example the process is same, the outline of the proof is same. That is, first denote the function surface by notation capital F, then curve by capital G, then consider df is equal to 0 and dg is equal to 0. That are equation 3 and 4. After solving these 3 and 4 by using Cramer's rule, find values of pqr, then write px dx plus q dy plus r dz is equal to 0 equation. That is equation number 5. And again the equation number the 3, repeat again this 3 as a equation number 6, and solve this equation number 5 and 6 we have this equation. So solve the solution of this equation. Solve the solution of, find the one single solution of this equation. This is the equation of the form dx by p dy by q dz by r, simultaneous differential equation. And so find its one single solution. In the previous chapter, uh, we have find there are two solutions. Here we find only single solution of this differential equation, either by using the first method or second method. That is, if we have the two ratios such that the third variable is absent, for example, the first and second, if you consider first and second ratio, equate the first and second ratio, then z is absent. So consider that two ratio, dx divided by minus x square minus y square, dy divided by minus x cube minus xy, and then separate the variables. So what we have, x dx, this if you take x square, x as a common factor from this, minus x as common factor, then we have in bracket x square minus y, and cancel that minus x square minus y of both sides. We have dx by 1 dy by x, that is x dx is equal to dy, and after integration we have x square by 2 is equal to integration of dy is y plus constant of integration c1. And so x square, if we multiply by 2 and write 2 here, first write c1 dash and write 2 c1 dash as a c1, then we have x square minus 2y is equal to c1. This is equation number 7. And write then 1 and 7. What is 1? 1 is the equation of the surface. So 1 and 7, write the last sentence that 1 and 7 gives the required orthogonal trajectories. Next example of the same type, find the orthogonal trajectories of the curve on surface x square plus y square is equal to z square tan square alpha of its intersection with family of plane paraboloid z is equal to c, z is equal to constant. So denote capital F as a function, as a equation of surface, that is x square plus y square plus z square tan square alpha is equal to 0, and denote by capital G as the equation of curve, and it is what, z minus c is equal to 0. Then consider df is equal to 0 and dg is equal to 0. What is df? The complete derivative of f, that is dy by x dx, dy by y dy, dy by z dz is equal to 0, and it is 2x dx plus 2y dy plus 2z tan square alpha dz is equal to 0, minus not plus, right, because it is what, right here minus sign, x square plus y square minus z square tan square alpha, and therefore its derivative is minus 2z tan square alpha dz is equal to 0. Dividing by 2, we have x dx plus y dy minus 2 minus z tan square alpha is equal to 0. This is equation number 3. And then equation number 4 is what, dg is equal to 0, that is dy by g by dy x dx, dy by g by dy y dy, dy by g by dy z dz. And then observe this g function, it is z minus c, therefore the derivative with respect to x is 0, derivative with respect to y is 0, and the derivative with respect to z is plus 1. So we have 0 dx plus 0 dy plus 1 dz is equal to 0, equation number 4. And solving this equation number 3 and 4 by using Cramer's rule, what do we have, dx divided by y minus z tan square alpha, here write dz, right, dz minus z tan square alpha, and then 0 1 second row, and the dy divided by, right here minus dy divided by x minus z tan square alpha, and the second row is what, 0 1, right, minus dy divided by, and then dz divided by determinant x y 0 0, and then we have dx by y, d minus dy by x means dy divided by minus x, and dz divided by 0, and therefore we have capital P, capital Q, and capital R as y minus x 0, and this PQ are the direction ratios of the tangent line to the curve, and this dx dy dz are the direction ratios of the tangent line to the curve which is orthogonal to given family, and therefore by condition of orthogonality we have that P into dx plus Q into dy plus R into dz is equal to 0, that is y dx minus x dy plus 0 dz is equal to 0. That is, we have this equation and is equation number 5. Then fx, fy, fz are the direction ratios of normal to the surface, and therefore fx dx plus fy dy plus fz dz is equal to 0. That is, we have x dx plus y dy minus z tan square alpha dz is equal to 0. This is equation number 6. Actually, this is equation number 3. The equation 3 and equation 6 both are same. So solving equation 5 and 6, we get by using Cramer's rule, dx divided by determinant what? X0 minus H0 and y minus z tan square alpha minus dy divided by determinant y0 and x minus z tan square alpha and dz divided by determinant y minus x and xy. And therefore, after solving this determinant, we have this value minus minus plus xz tan square alpha minus 0, then minus yz tan square alpha, and this is y square minus y square minus plus x square. So it is the term y minus x, and the second equation is xy. So it is my y square minus plus x square. So write y square plus x square at this place, y square plus x square. And then we have dy divided by yz tan square alpha. So here is y square plus x square. Actually, this is the term y square plus x square. And then we have to find the solution, single solution of this equation number 6. So apply the first method, that is consider the first two ratios, and then tan square alpha and z get cancelled, and therefore we have dx by x dy by y. That is, one variable z is absent, and then separate the variables. So 1 by x integration is log x, 1 by y integration is log y. So minus log y is equal to log c1, and then x by y is equal to c1. Log x minus log y is log x by y, and so x by y is equal to c1 after cancelling log on both sides. And then it is equation number 7, and then 1 and 7 gives the orthogonal trajectories. The next example of the same type, show that the orthogonal trajectories of the hyperboloid x square plus y square minus z square is equal to 1 of the conics in which it cuts by the system of the plane x plus y is equal to c are its curves of intersection with the surface x minus y into z is equal to k. So the equation of surface is what? X square plus y square minus z square minus 1. So it denote it is by capital F, and capital G is what? X plus y minus c. It is the equation of curve. So find first df is equal to 0 and dg is equal to 0. So df is equal to 0 means df by x dx, df by y dy, df by z dz is equal to 0. That is, the derivative with respect to x is 2x, with respect to y is 2y, and with respect to z is minus 2z. We have this equation. After dividing by 2, we have the equation number 3 as x dx plus y dy minus z dz is equal to 0. Similarly, dg is equal to 0 gives g by x dx, g by y dy, g by z dz is equal to 0. And then derivative with respect to x is 1, with respect to y is 1, with respect to z is 0. So we have this equation 1 dx plus 1 dy, and this is equation number 4. Solving 3 and 4 by Cramer's rule. So dx divided by y minus z as first row, and the second row is 1 0, minus dy divided by the first row is x minus z, and the second row is 1 0, and dz divided by x y as first row and 1 1 as second row. And then after solving the determinant, we have answer 0 minus plus z, that is z, then 0 minus plus z, that is right z, and after shifting this negative sign, we have dy divided by minus z. Actually, this is dy divided by minus dy divided by plus z, and so dy divided by minus z, and then x minus y as a dz divided by r. And so PQR are what? Comparing this with the equation dx by p, dy by q, dz by r. We have p is here, q is minus z, r is x minus y. And these pq are the direction ratios of tangent line to the curve, and dx dy dz are the direction ratios of tangent line to the curve which is orthogonal to given family. And therefore by condition of orthogonality we have p dx plus q dy plus r dz is equal to 0. That is z value of p z z dx minus z dy plus x minus y dz is equal to 0, equation number 5. Now fx, fy, fz are the direction ratios of the normal to the surface, and therefore we have fx dx plus fy dy plus fz dz is equal to 0, again by using the condition of perpendicularity, orthogonality. So we have x dx plus y dy minus z dz is equal to 0. And solving this equation 5 and 6 by using Cramer's rule, we have dx divided by this determinant minus z minus z x minus y minus z, then minus dy divided by z x minus y as first row and x minus z as second row, dz divided by z minus z as first row and x and y as the second row. And solve this determinant, we have these values. So, and we have to find a single solution of this differential equation. We have to find a single solution of this differential equation. Either use the first method or second method, that is find the, consider any two ratios in which the third variable is absent, or the second method is what? Find multipliers, and such that suppose the LMN are the multipliers such that LP plus NQ plus NZ is equal to 0. If it is the second method fails, then apply the sub method of second method. This is the sub method of second method. That is, consider the multipliers 1, 1, 0, 1 minus 1, 0, and in the place of each ratio, consider the third ratio, this third ratio. So the multipliers are 1 minus 1 0, so we have dx minus dy as multiplied by 1 and multiplied by minus 1, we have this. And then consider the third ratio in the place of each ratio, consider the third ratio, that is dz yz plus xz. And if you substitute, if you take common this z and shift, then it is 1 by z right here, it is not z, it is 1 by z dz right here, 1 by z dz. Okay, and then right here 1 by z dz, if we take z as common and if we shift this z to numerator, then it becomes 1 by z dz. So right here 1 by z dz, correction is there. And this is the z square minus xy plus y square. Adjust this factor such that the derivative of denominator is the numerator. So if we multiply this by 1, then we have z square minus xy plus y square, minus, if we multiply by minus 1, then minus z square minus x square plus xy. And what we have, z square and minus z square cancel, minus xy plus xy get cancel, and so what we have, y square minus x square as the denominator, that is x square minus y square, take minus sign as common, and then numerator is dy minus dx, absorb this negative sign at numerator. And then the factorization of x square minus y square is what? X minus y, x plus y. And then if we cancel x plus y, then we have minus and take negative sign as common, so we have minus in bracket dx minus dy divided by x minus y as the denominator. And here write 1 by z, it is 1 by z dz, and then its integration is what? Minus sign, and x minus y derivative is dx minus dy, and therefore by using rule of integration, that integration of f dash x divided by fx is log fx, so log x minus y. Similarly here is 1 by z, so its integration is log z plus add the constant log c1, and then minus log x minus y minus log z, take minus sign as common, so log x minus y plus log z is log x minus y into z, and cancel the, and then we have the answer log x minus y into z raised to minus 1 is equal to log c1, and cancel the log of both sides, so we have x minus y into z raised to minus 1 is equal to c1, and take the reciprocal of both sides, we have the answer x minus y into z is equal to c1 dash, another constant, and it is equal to, suppose, equation number 7, and then 1 and 7 gives the orthogonal trajectories of 1. So correction is there. Write 1 by z in the place of z, and write here log z as the integration of 1 by z, and it is equation number 7, and then write 1 and 7 gives the required orthogonal trajectories of the equation number 1 of the given equation, not equation number 1, of the orthogonal trajectories of given equation. Then find the orthogonal trajectories of the on the cone x square plus y square is equal to z square tan square alpha of its intersection with the family of planes z is equal to 0. So this example number 5 and this example, find the orthogonal trajectory of x square plus y square is equal to z square tan square alpha, its intersection with the plane z is equal to c. These two examples are same. In the place of z is equal to c, in this example z is equal to 0. So write the capital F and capital G and apply the all procedure. We have the answer. X square plus y square plus z square tan square alpha is 1. We have the answer x is equal to c1y. X is equal to c1y, or x by y is equal to c1. Similar to this example, we have the equation number 7 as. So this is the equation number 7. Equation 7 is what? 5. The equation 7 is x by y is equal to c1. So in this example also we have the x is, and then 1 and 7 gives the orthogonal trajectories. That is this answer, that 1 means x square plus y square is equal to z square tan square alpha, and 7 means x by y is equal to c1, gives the orthogonal trajectories, required orthogonal trajectories. So these are some problems for homework. Find the orthogonal trajectories with the intersection of planes parallel to the xy plane. So if the plane is parallel to xy plane, then its equation is z is equal to c. So take the equation of curve as z is equal to c. The plane is parallel to xy plane means z is equal to constant as the equation of curve. That is, take g as a z minus c is equal to 0. And this is the equation of surface x square plus y square plus 2fyz plus d is equal to 0. Consider these f and d as a constants, arbitrary constants. The next example, find orthogonal trajectory on this surface, on the sphere, that this is the surface x square plus y square plus z square is equal to a square of its intersection with parabolas xy is equal to cz. So this is capital F as x square plus y square plus z square minus a square as is equal to 0, and xy minus cz as a equation of a curve, that is capital G. And find the answer. Find the next example. Find the equation of system of curves on the cylinder 2y is equal to xy, orthogonal to its intersection with hyperboloid one parameter system xy is equal to z plus c. So this example and the previous example. So show that the orthogonal trajectories of hyperboloid x square plus y square minus z square is equal to 1. So in this example, yes, 2y is equal to x square. Y is equal to x square, orthogonal to its intersection with the hyperboloid xy is equal to z plus c. So already the answer of 3 is given in this discussion. So only solve equation number, problem number 1, 2. Show that the problem number show orthogonal trajectories of the hyperboloid of conic in which it cuts the system x plus y is equal to c of its intersection with x minus y z is equal to k. So the answer of this problem is what? Show that. So this is the answer. X minus y z is equal to k is the answer. So already answer of this problem is also given. Show that this problem. So show that the orthogonal trajectory of the hyperbola of its intersection with x plus y is equal to c is this x minus y into z is equal to k. So the answer is this. So answer is x minus y into z is equal to k. So correction is there, 1 by z, right here 1 by z, and then we have the answer x minus y into z, x minus y into z is equal to k. So this is the answer actually. Answer is given. Show that. Question is what? Show that the orthogonal trajectory is this x minus y z is equal to k. So the final answer here, x minus y z is equal to constant, either k or c1. So already the answer of the problem number uh, 4 is also given. Find the next problem. 5 is what? Find the orthogonal trajectories on the conic x plus y into z is equal to 1 of the conics in which cuts the system of planes x plus x minus y plus z is equal to k. So again solve this problem. Denote by capital F and capital G as equation of surface and equation of curve, and solve the procedure by using procedure. So the solve some another solve problems. Find the orthogonal trajectories on the cone x square plus y square is equal to z square tan square alpha in its intersection with z is equal to 0. So this is the answer of the problem number, exercise problem number, z is equal to 0. So yes, this is the problem. Z is equal to 0. Find the orthogonal trajectory of the cone x square plus y square z square tan square alpha. So this is the answer. Next problem is find the orthogonal trajectories on the conic at x plus y z is equal to 1 of its of the conics in which it cuts the system of planes x minus y plus z is equal to k. So denote the equation of surface by capital F and the equation of curve by capital G, and solve the, by using the procedure. So we have this answer. Also these are some problems for exercise. Find the orthogonal trajectory on the surface x square plus y square plus 2fyz plus d is equal to 0. Again the same problem. Uh, of its curves of intersection with planes parallel to xy plane. So if the plane is parallel to xy plane, then its equation is z is equal to constant, z is equal to c. That is, take z is equal to c as a equation of curve and find the answer. We have this answer. Find the equation of system of curves on the cylinder 2y is equal to x square. Actually, this is solve problem. Equation problem number 2. Then problem number 3 also discuss. Problem number 4, show that the orthogonal trajectory. This problem is also solved problem. So solve all the problems of orthogonal trajectories, and this topic is important as far as exam concerned. So solve all the exercise. Now we'll start the next topic in the next lecture.